45, convert 0.000314 into scientific notation. Scientific notation, as you probably remember, is a method of writing numbers that are really, really big or really, really small. Of course, this one is really small, and having to write down and keep track of all of these zeros, kind of a hassle. Likewise, if you had a number that's in the billions or trillions or something, you don't have to write all those digits down. So scientific notation gives us a very compact way of writing those, but it has to be written in a specific way. So I'm going to generalize it right down here. I'm going to write a scientific notation number like this. It's going to be some number which I'll call A. You'll multiply it times a power of 10. So times 10, and that power I'm going to put as a B. Now, the A, the number that you're multiplying times a power of 10, can't be just anything. It has to be between 1 and 10, but it can't be 10. So it has to be greater than or equal to 1 or less than 10. If it was 10 or bigger, then that means there could have been another power of 10. So that's why there's no equal sign here. Now, finally, this B over here, it's a power of 10. And for our purposes, that is only ever going to be an integer. Integer power. So for example, a positive or a negative 5. So let me give you a couple of examples here. Let's say I have 3.7 multiplied times 10 to the fourth power. So what I usually do here is this. I take my number, 3.7. I'm going to add some zeros to the end of this thing, and now I'm going to move this thing to the right, a positive 4. If you were to basically take any kind of number, let's say you have 12, and you're going to multiply this thing by 10, well, the shorthand way of doing that is just adding an extra 0 here. Sure, you can do this by long multiplication. Go 0 times each of these, and you just get a big old 0. Bring down a 0 placeholder. Now you multiply this 1 times everything, and you get 12. And then you add those two columns. 120 plus a 0 doesn't do anything, so why didn't I just go with 120? So really what I'm doing there is I'm just adding that 0 to the end. The same thing is happening here, it's just that we're going to add 4 of those zeros. And that's going to move my decimal place over 1, 2, 3, 4 places, and then keep track of those. So as far as it goes, I didn't actually add 4 zeros. And the reason why I didn't add 4 zeros is because when I multiplied this by the first 10, it just made that 37 instead of 3.7. And it was 3 zeros that got added to the end of this. So it becomes the number 3, 7, 1, 2, 3, so 37,000. Okay, so in general, if you have a positive power, then this means move decimal to the right. All right, now let me change the problem up just a little bit here, and let's say that I have 8.36 multiplied times 10 to the negative 3 power. Okay, when it is a positive power, move the decimal to the right, the number gets bigger. When the power here is negative, it's going to be a small number. To make this thing smaller, we're going to move this decimal place to the left. And to do that, I'm just going to add some zeros to the front of this thing. How many do I add? I don't even know. Or do I? So 8.36. Okay, so I'm going to move this decimal place over 1, 2, 3 places. So notice that I added 2 zeros. The reason why I added 2 zeros is because when I move this to the left, that's going to take away one of these little powers, and then there's going to be 2 of them left, so I needed 2 zeros in front of that 8, so 0.00836. So those are the kind of things that you're doing on question number 45, but it's kind of backwards here. So let's say that I work these two kind of problems in the other direction. Let's say that I have my numbers that are in non-scientific notation, and then we're going to try to write them into scientific notation. So make up some crazy number like 46800000000. Okay, now whenever I go to make this in scientific notation, I'm just going to keep track of my zeros, and I just want to focus on the significant figures that are right here at the far left-hand side of my number, the 4, the 6, and the 8. And we're just going to move our decimal numbers over to the left from this position and keep track of them. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this number becomes 4.68 times 10 to the 9th. Okay, let's do this one more in the opposite direction. And this time I'm going to have, say, 0. 0.000000521. Okay, so our significant figures in this case are all the last digits here. I should also keep in mind that I'm going to have a negative exponent because it's a tiny number, and I need to take this decimal, keep track of it, and see how many spaces I need to move it so that it's in between the 5 and the 2. And the reason why I need to be in between the 5 and the 2 is because, remember that this number that you multiply times power of 10 has to be between 1 and 10. Likewise, that's the reason why I made my decimal number on this previous one in between the 4 and the 6. Okay, so keeping track of my decimal number, I'm going to move this 1, 2, 3, 4, 5, 6, 7, 8 spaces. So my number becomes 5.21 times 10 to the negative 8 because I made it tinier. All right, so like I said, that's exactly what you're doing over here on question number 45.